Hey guys, your boy Chili here. Welcome back to C++ Infrastructure. We're coming back at you with the IOC container, and today we're going to look at how we can handle singletons, some global shared objects in our service container. So right now, our container maps type to this any, which is actually a generator. It's a factory function that returns an instance of that type, right? Now, what we're going to need to do is now it's not only going to be able to hold a generator in here, but it might also hold an actual instance. If it's a singleton, a global instance that will be returned every time you try to resolve. Same instance will be returned, and that way we can share it. And it won't be two options. There's going to be three options of what could be stored in here, because we're going to allow for deferred construction of our singleton. So you can register a singleton with a generator. And what happens then is the first time you try to resolve it, it will use the generator to create the actual instance. But subsequent resolves will just return that same created instance, and you won't need the generator anymore. So we're going to have three options as to what you can have in here. You can have a generator that is used just for resolving separate instances as a factory, a generator that is used to lazy resolve and create a singleton, or an actual singleton instance. Three options as to what can be in here. Now, what I might do in this case like this is I might try to use std variant, but because of the templated nature here, we don't really have an easy list of options as to what can be in here. So I'm just going to use std any together with an enumeration, and we'll just handle it manually like that, and that'll probably be an easier solution. All right, so we need some additional data types. We'll just make it as a nested type inside of container. It's going to be private. The outside world does not need to know about these details. I'll just make the section here types and enum class state. So this is going to hold the state of any given entry in our map, and the state, there's going to be three states. So it could be an instance generator, which is held. It could be a singleton generator, or it could be a singleton instance. So these are three options. And we need now a struct entry that is going to be the entry in our map, because we need to put the state information together with the actual content being held. Okay, so now we are going to map from a type to an entry in here. Well, first let's add a register function that registers a singleton generator. So template class T. We'll get to why it has to be class T in a second, but we'll do void register singleton generator type. So the starting is the same. We want to look up into our factory map in here. I guess factory map is a kind of a bad name for it right now, but I don't feel like refactoring that. But it's not just factories that are in here anymore. It could also be instances. So if I cared more, I would change it, but we'll live with it. All right. So this part is the same, but now what we have to put in here is an entry. So it's not just a generator, it's an entry, and the entry contains two things. It contains state, and this would be singleton generator, and then it contains the actual generator. Could do something like std move gen. Sure, that looks good. All right, there we go. And so there we have, now we've registered our singleton generator into the map. Now we have to change these ones again as well, because we have to create entries and put them into the map. So I'm just going to copy and paste this. We move the generator and... No. All right, so now this is not a singleton generator. This is an instance generator here. And this one should be an instance generator here. Now, you look at this, you say, well, we have a register a singleton that takes a normal generator. Shouldn't we have a version of this that takes in a parameterized generator? And the answer is no. Making your singletons so that you can resolve them with parameters doesn't make sense. Because the first time you resolve it, yes, you could use those parameters. But the second time you resolve it, the instance is already created. If you resolve it with any parameters, they're just going to be ignored. And making your interface where you can pass in parameters that may or may not do something is a recipe for just creating headaches down the road. People are going to be trying to resolve an instance with parameters and then wondering, why isn't it not, respecting my parameters? You must respect my authority, and so forth. So I think a generator, or for singletons, when you resolve it, you should only be able to resolve it with no parameters at all. All right. So then you might be asking, well, why did you make this class T? Why didn't you narrow it down to not parameterized? Well, I would like to be able to register things as singletons, even if they are parameterized. I would do the parameterization internally. I wouldn't allow you to resolve with parameters, but I should still be able to use those classes as a singleton if I wanted to. So we should not narrow it down. We should accept anything, but we will use it without the parameters. Okay, so that is the registration taken care of. All right, here's where things are going to get a little bit tricky. Now we have to implement our resolve so that it can resolve sort of works for either a singleton or an instance generator. So how do we do this? Well, we have the state variable here in every entry. We're going to have to refer to that to determine what action we should take. So to keep things clean here, we're going to forward, I wouldn't say forward declare, but declare ahead of time shared pointer T. And now we have to figure out how we're going to fill that before we return it. So we're going to switch. Well, I guess here what we should do first is so when we get out this I, it is going to be auto entry. It's going to be a pair. And if we do I pointer to second, so this should be our entry type. Yes. All right. So we'll just put a little shortcut in there to make our code more readable. And we're going to switch on entry dot state. So what state are we in? And a case, first case, state, instance generator. What do we do in that case? Well, we basically just do what we were doing before. So we do our anycast in here, we forward the parameters, and we put the result of that into this pointer variable. And then we break. So that's easy one. All right. Second one, state singleton generator. So here's where things get a little interesting. It's going to be similar in that we're going to construct an instance here. So let's copy that. Now here's the thing. Because it's a singleton, we should not pass any arguments. So we can just forward. We could do forward and it should be 0 arguments. They should never try to resolve a singleton with arguments. But we don't need to put that in here because it should always be no arguments. So we can just eliminate that. So we set our pointer. But now what we have to do is we have to store that singleton instance so that it can just resolve the instance on subsequent calls. So we should say entry.content is now equal to that shared pointer. And very important, we have to update the state of the entry to be state not instance generator. Thank you very much. Singleton instance. So now it is storing an instance of a singleton, not a generator. And then we break. And in the third case is we already have an instance, so we don't need to generate. So in that case, the thing that we're going to return, we should just do an anycast std shared pointer to our resolved type T on the entry content directly. And then we break. There you go. And of course, we've set up this PTR, so we should now return that from our function. So if all goes well, we'll hit one of these three and we'll return that. Now, this is not correct, right? I2nd, which is our entry type name. All right, so there's a problem. So that should be the entry dot content. That's an std any. Then the type of that, the name of that type. And there you go. I think that actually does it. That wasn't too bad, I don't think. Let's just see if it compiles. Doesn't. Okay, so I messed up something. Term does not evaluate to function taking 0 arguments. All right. So it looks like, yeah, when the template instantiation happens, it could turn out that G is something that requires parameters. So even though this branch will never be hit, we still have to satisfy C++'s OCD, we still have to do this. So that was actually necessary, which I guess that, yeah, that makes sense. Okay, so it builds, everything works. So without changing any of the code here, let's just see if it works as before. Yeah, that looks right, I guess. It's been a few weeks, but it looks like what I would expect. Now, let's try to put a singleton in here and see if it works. So we're resolving component A with parameters, but we're not resolving component D with parameters. So let's see if we can just change this to a singleton. Yeah. And enhanced components. D is morb. Run that. Yeah, okay, so that seems to have also worked properly. Now, we want to verify that this is actually a singleton. So let's just make a little modification here that should allow us to make that clear. All right, let's add some state to component D. That will make it clear as to whether the same instance is being used multiple times. String text is equal to hello. Okay, we'll make this, spice it up a little bit. We'll make this private. And in the public, we'll make a function void set text string t text is equal to move t. There. All right, so we'll put a little setter in there. And then for do processing, we should return D plus text. All right. So this is the base behavior of this bad boy. We'll run this just to make sure it doesn't do anything super weird. Yeah, because we overrided it. It's not using the text anymore. In here. So let's change our enhanced component D now. Do processing should return morb plus component D, we'll call the base processing. There. So that'll be morb plus D plus text. So now if I do that, it should say morb D hello, better C. Yeah, okay. Perfect. So now what we want to do is we're going to register a singleton for component D. We're going to resolve out a component D here. So auto D is equal to container get resolve component D, and then we're gonna do D pointer to set text. Booyah. And what we should see now is when we resolve out A, it is going to resolve out D again, but it's going to get the same one that we resolved out here, and so it should be modified now to show booyah. There you go, more D, booyah, better C. Oh, there you go. So now we have a singleton. It is doing, you know, it's using the same instance multiple times, no matter where it's resolved from, which can be efficient, can be what you want to do. All right, let's try one more thing here. We're going to register component A as a singleton. We're going to see what we see. So we'll do component A. All right. So we'll just return a default one. So let me just go back to component A because it's been a while. Go to definition of component A. And so it actually requires component B, and it requires IOC params. IOC params can be default constructed because it's just an optional and a string. So we need to resolve out component B here. So we'll resolve component B. And for the second parameter to the constructor, we need component A, IOC params, and we'll just default construct those. Okay, so now we have a singleton. It should get all the defaults and everything should be fine. Could not resolve services mapped type from function shared pointer blah to function shared pointer that takes in an IOC params. Okay, so this is telling us what the problem is, but it's not particularly easy to read. We could make this better. And the problem is we registered this as a singleton, but now we're resolving it with parameters. And singletons don't support resolving with parameters. So that's a bit of a problem. And yeah, the diagnostics on that aren't the greatest, but we can improve them slightly with a little test in here. So the only thing that can resolve with parameters is an instance generator. Singleton things don't accept parameters. So let's check. So if entry.state is not state underscore instance generator. So if we're not an instance generator and somebody has passed in some parameters, so size of, this is template meta programming parameter pack thing, the size of this pack type is greater than 0, then we have a bit of a problem on our hands. So let's throw std runtime error, and I would like to create a custom exception type for my container, one or more custom exception types, so you can filter on them. But we don't worry about it. Parameters passed in while resolving a singleton. So that's the error. And now if I run this, yeah, we can see here that we get an exception. Parameters passed in while resolving a singleton, which is no bueno. We should just try to resolve component A without any parameters, and we will get the singleton. Why do you make a liar out of me, C++? Okay, what is your problem? Parameters passed in while resolving a singleton. Resolve component D. It's not done there. Okay. All right. I done messed up somehow, maybe. We'll put a breakpoint where this exception gets thrown, and we will look at the call stack. So when we resolve A, params, Interesting. So it always passes in params if it's a parameterized T. Always takes in params for that one. So the problem is that because component A is defined as parameterized, the compiler will always select this version. And when we pass it in with 0 parameters, it will create a default constructed one and pass that over to our implementation function, resolve underscore. But what we want to be able to do is if we are resolving a singleton, we don't want to pass in parameters. Now, the way this is designed is that when you're resolving, it is actually transparent as to whether you're going to get back a singleton or not. So we don't have that information when we are resolving. And that, I'll talk about it a little bit at the end of the video, but that might not be the way to go, just to be clear. You might want to make that explicit. But we'll solve the problem as given. And in that case, what I would do is if you want to resolve a default IOC params, you'll just have to default construct it yourself. So we'll create 2 versions of this, one that has params and one that has nothing. And the nothing one, we'll just call this function with nothing. And it's parameterized, but we're going to call it with nothing at all. So you better hope that it's a singleton. Oh yeah, if you're going to resolve with no parameters, you shouldn't say that your generator type is a parameterized generator. That makes sense. All right. It works. And it works. Okay. So, I mean, that's one way to solve it. And what we could actually do here is we could put another test to check, okay, so if we are an instance generator, then we should have parameters. So if we are an instance generator type, but they didn't pass in any parameters, you know, that's a bit of a problem. No parameters passed in while resolving an independent instance. Quick little addition here in post. I didn't actually run the code after adding this in here. I just figured it would work. Famous last words, because after you add that, it doesn't work. Okay, so what's the problem here? I mean, the logic is that if we're an instance generator, then we should have parameters passed in. But is that true? Because even if we're an instance generator, if the type T is not parameterized, then we shouldn't have parameters passed in. So we need an extra condition here. If we are an instance generator and T is parameterized, and parameterized T, we can use concepts like this to just do a check at compile time. Is T a parameterized type? If it is, and we are an instance generator, then we need some parameters passed in. It can't be 0. So if I run this now, yeah, now it works as you would expect. Okay, just a little bit of I dotting and T crossing there for you. But yeah, that's basically it. And you can see here, we're running into a little bit of ugliness when we try to resolve singletons out from our service container. And I think there's actually a few problems with this approach. I've actually used this approach before, and I haven't run into problems, but I can anticipate there being some serious problems with it. A lot of times in programming, like you like it when things are opaque, right? You like it when it's like, okay, I resolve out a component and I don't care what the actual concrete implementation is. I don't even want to know if it's a singleton or an independent instance. I don't want to couple myself to that information. I want to keep it all decoupled. Just give me something that I can use and I'll use it. And that is often a very good thing. But with singletons, right, there's also the problem is because like if I resolve something out, it's a singleton, other things might be using the same thing. Now I start to modify it. I'm affecting other things, but I'm not aware if I'm actually affecting other things. That might be a problem. If I'm making changes that might break other stuff, maybe I don't want to resolve out a singleton. Maybe I want to resolve out an independent instance. But if you make it opaque, that could lead to issues. I could see that happening. And another problem with this design here is, okay, so I registered something as a singleton. What if I know that I want to resolve out an independent instance? I can't do it, right? Because resolve will always give me back that singleton. So because of those issues, I think what is a better solution is keep the container as only something that can resolve out independent instances and create a separate class, which is your singleton container. And what that singleton container will do is it'll hold the singletons, and when it needs to, create things for singletons, it might use the independent instance creator to construct those instances the first time, and then after that it'll just return it from your singleton container. But by doing that, you can remove these weird instances here and these weird checks here. You won't need them, so the code will be a little cleaner. You won't have this ambiguity when you're resolving a singleton. Do I need params? Do I not need params? It's not clear. The component declares that it takes in parameters, but if it's a singleton, I shouldn't pass in the parameters, right? And it'll allow you the option of, okay, so if I call container resolve, I'll get out an independent instance. If I call singletons resolve, I'll get out a singleton. So I'll have the choice there. So that's why I recommend separating the singleton container from your IOC container. But I mean, like I said, I put them together when I first tried this stuff out, and it worked fine for me, mostly because I think the things that I was using as singletons, I never wanted to resolve them out as independent instances, and vice versa. So I just never ran into that wall. But I think if you use it extensively, you will eventually run into that wall, and so it's better just to keep them separate. So that's what I am. And I might explore that sometime in the future, but I think I'm done with this IOC container stuff for making YouTube videos, at least. So I could go on. I could probably make like 20 videos on this with all the different enhancements and all the different use cases. But this is the basics, right? This is the basics, and I might add more to it because I'm going to, like I mentioned this in an update video, but I'm planning on this C++ infrastructure series. I'm planning on doing a whole bunch of different stuff and building up the core of something like a game engine, right? All the core services that support that. And as I'm doing that, I might even add more to the singleton. I might separate it out like I talked about. But for right now, we're going to move on. And we're going to actually, I think in the next video, we're going to lay the foundation for a 2D game engine. And that game engine will include this IOC container or something very similar. But it'll also have a whole bunch of other stuff that we're going to build up and learn about. Lots of core infrastructure utilities and code base, and also a lot of developer experience stuff, how to set up a project and a build to be very nice in Visual Studio. We're going to be using MS Build for this stuff. So that'll be interesting for a bunch of you, I think. But until then, thanks for watching. I hope you liked this video. If you did, please click the like button. And I will see you again with some more C++ infrastructure. We're going to start our 2D engine foundation building.